Good morning, good afternoon. Thank you for joining the U.S. Aluminum Association, European Aluminum, and Ducker Carlisle today to examine demand for automotive aluminum in Europe and North America through 2030. I'm Craig Lewis, the Vice President of Strategic Transformation at Constellium. Constellium is a global leader in the production and recycling of aluminum products. We manufacture innovative and sustainable aluminum solutions, mostly for the packaging, automotive, and aerospace markets. We're also a major recycler with the capacity to recycle the equivalent of more than 32 billion cans, and we can also take in automotive scrap in our facilities worldwide. Constellium has generated 8.1 billion euro of revenue in 2022. I'm also the chair of the U.S. Aluminum Association Transportation Group, or ATG. Through technical research, advocacy, events, and more, both associations work to communicate the benefits of aluminum adoption in automotive applications. Pleased to host this event with my colleague Florian, who I'll let introduce himself.
Thanks, Craig. Hello, everybody. My name is Florian Stadler, and I'm currently serving as the chairman of the Automotive and Transport Board of European Aluminium. I'm also managing director of AMAG Rolling, which is based in Ranshofen in Austria. AMAG is Austria's biggest aluminum manufacturer with a very broad product portfolio of primary aluminum casting alloys, as well as rolled sheets and plates. In addition to automotive sector, we are also very active in the aircraft industry, where we also deliver machine parts, as well as in foil stock, building and construction, and special products business. We are actually one of the biggest recyclers here in Europe, and we have a very long tradition and experience regarding the production of sustainable, low-carbon aluminum cast alloys and semi-finished products. So, Craig, do you want to introduce our two experts of today?
Thank you. Today we're speaking with Abby Abraham, principal at Ducker Carlisle, with over 17 years of experience in the North America automotive materials, mobility, and manufacturing sectors, as well as consulting. We also with Helene Wagnes, principal at Ducker Carlisle in Europe, with 20 years of experience in market intelligence and consulting, leading the European auto materials practice. Ducker Carlisle has supported the U.S. Association and Aluminum Content Analysis since 1996, and the European Aluminum Association since 2012. So let's jump right in. Abby, Helene, would you be so kind and shortly introduce your company for those who do not know Ducker Carlisle?
Sure, thank you, Greg. So here's Helen speaking. Hello, everyone. So Ducker Carlisle, for the one who do not yet know us, is a global market research, strategy consulting, and M&A advisory firm. We deliver tailored assessments to de-risk strategic decisions and custom solutions to help our clients improve their performance, grow their business in general, either organically and or inorganically, depending on the challenge you are facing. Ducker and Carlisle merged last year in March, with, on the one hand, Ducker bringing the market intelligence and M&A transaction support services in the DNA of the group, and on the other side, having Carlisle bringing 30 years of expertise in pricing strategy and revenue management consulting, also benchmarking and supply chain operational excellence. So in terms of industry segments, we have historically been very strong in automotive and transportation, as well as in the heavy equipment verticals. Both sectors we worked for since our very foundation in the early 60s. We have also rapidly extended our areas of expertise to other verticals, like building and construction, healthcare, and other industries such as chemicals or energy, packaging, and so on. But all industry sectors we are active in have in common that they have to deal with complex value chains and also market environments where typically the technology plays an important role. And I would say that our exposure to various industry verticals allow us to identify trends and solutions that are being implemented in certain industries, but that can also be used for benchmarking or as a source for inspiration in other industry segments. And we have also grown our international M&A transaction advisory practice I would say, in the last 2 decades, and our coverage of M&A transactions with both corporate clients and private equity company allow us to capture early indicators on where investments are being made and where trends are headed. In terms of geographic footprint, so our capabilities and expertise is truly global, with the geographic coverage that mirrors our global footprint and allows us to serve our international clients with local presence across the globe. So I think that would be enough about our company. Let's dive into the subject.
Thanks, Hélène. That's actually very impressive expertise we are talking about here. Now I would like to set the scene for this webinar a bit. This year, Ducker Carlisle has published the latest reports about aluminum content in cars in both North America and the EU. And these reports, they provide detailed analysis on current and forecast aluminum usage and the impact of electrification in both regions. So specifically, if we talk about the adoption of battery electric vehicles. And this was also the first time that the European and the US studies have been synchronized to be conducted in parallel at the same time, and that regional comparisons were included in the analysis. I don't want to reveal too much now, but Ellen, Abby, your assessment of the aluminum content in cars shows a very bright outlook for aluminum in both regions. But it's obvious that there are still major differences between the two markets that will be pointed out by you in the following. But before we jump into the results, Abby, could you please explain what your methodology is to conduct a study like this too? How do you generate your data?
Thank you, Florian, for introducing the projects we had completed on behalf of both of these world-class associations. Ducker Carlisle has been fortunate to have decades of expertise in monitoring and assessing the automotive materials market, which really translates to a successful track record of completing hundreds of aluminum and materials-related projects for corporate clients and associations around the material supply and value chains, their applications, the new innovations, and more important than ever, recycling. These projects contribute to our expertise and knowledge base that we leverage to deliver our results. And throughout these projects, we've built relationships that have been fostered with OEMs, suppliers, and mills that help discern facts from noise and allow us to arrive at the facts versus the opinions. I'm going to share a slide here just to kind of illustrate that a little bit more. Throughout the last 2.5 decades, we've developed a proprietary database to truly accomplish a bottom-up build of aluminum content per vehicle by product form, which includes castings, sheet content, extrusions, and forgings, as well as the competitive material threats and outlook that we need to monitor and react to. We collect both qualitative and quantitative insights from decision makers at the engineering level, product management, and sales levels that are really involved in our knowledge and knowledgeable of the material selection. And we really gain a deep understanding of why certain materials are selected or favored going forward.
Thanks, Abby. Is the approach the same in both North America and Europe?
Yes, absolutely. Great question, Craig. Ultimately, we apply the same methodologies, the same rigor, and the same approach in both regions. And although we're not currently engaged in an association-based study in Asia, our automotive and materials teams located in Shanghai and Bangalore and Delhi have the same capabilities and expertise to conduct a similar study.
Thanks, Abby. We are all curious now. So, Hélène, what are the major takeaways from your latest reports? Let's start with Europe.
Okay. So our latest assessments of the aluminum content in passenger vehicles for both associations confirmed, first of all, the uninterrupted growth of aluminum in automotive applications. You can see it on these slides with the two curves, the blue one for Europe and the dark green one for North America. So that's already a key takeaway. An uninterrupted growth driven by what? First of all, by the ongoing need for further lightweighting in general in order to decrease the CO2 emissions, whilst we have been keeping on adding electronic and safety content in cars in the last decades. More recently, driven by a rising share of larger and premium vehicles, specifically in Europe, which typically both have the large and the premium vehicles, a higher aluminum content per vehicle on average, and also driven by, strongly driven by the electrification. Electrification creates new applications around EV-specific components, such as the e-drive housing and the battery housing. There are many more, but these are the biggest ones. And electrification also implies, as everyone knows, heavy batteries, especially if we are talking about battery electric vehicles. These heavy batteries add mass to the vehicle, and this mass needs to be offset. Why does it need to be offset? Because you don't have the type-up emissions, but still you need it in order to meet the customer expectations in terms of range, in order also to ensure still to have a good vehicle handling and good riding behavior. And also because reducing the vehicle weight allows you to use smaller batteries, and with that, to lower the battery cost. So that's why the lightweighting remains very important, and even more important with electrified vehicle. And the uninterrupted growth of aluminium is also fostered by innovation, such as large and mega casting, which will contribute in the midterm to growing aluminum content in the body in white. Beyond the large and mega casting, if we look at the body in white component family, you have quite a few interesting dynamics there regarding aluminum usage. For instance, drastically growing adoption of aluminum shock towers, which is visible for everyone in the industry. Also an increasing penetration of aluminum for crash management systems, so bumpers and crash boxes, and also an increased utilization of bigger door seals in order to protect the BEV batteries in crash situations. So all in all, the aluminum demand for body in white is anticipated to more than double in Europe. So that's huge. And by 2030, body in white will even outpace the category wheels in terms of aluminum demand. And for people who are already knowledgeable about it, historically, wheels were always the first market for aluminum in automotive applications. So that's an important message to understand that wheels will no longer be the first consumer for aluminum in automotive. If we look at the other component family that you see on this chart, it is no surprise that the category ICE powertrain, so internal combustion engine powertrain and transmission, will drop with the electrification, and at the same time that EV-specific components will be booming. And it's a strong takeaway as well to realize that by 2030, EV-specific components will have become the largest of all component families in terms of aluminum demand. Of course, provided that the adoption of BEV is progressing as anticipated. And when it comes to other component family on the chart, chassis, for instance, you see will also experience very dynamic growth, driven by higher lightweighting need in BEVs, and also more aluminum knuckles, and as well more one-piece cast aluminum subframes. And if you look at closures, we'll see also further growth there, which has historically been a very important category for aluminum demand. So I think that would summarize some key takeaways for Europe. I hand over to Abby for North America.
Sure. Yeah, I think, Helene, you've captured most of the themes we've identified in both of the regions. There's some similarities there. One of the key differences, however, is in the production mix of the vehicles, with about 3/4 of the light vehicles produced in North America being classified or categorized as light trucks, which include pickup trucks such as the Ford F-150 and large SUVs like the Lincoln Navigator or the Cadillac Escalade. The North American vehicles are just larger overall than in Europe, which really drives a higher average aluminum content per vehicle, which we'll get into a little bit more detail, about 50 pounds or 22 kgs higher than in Europe on average, right? Similarly, as we look at the size segments between North America and Europe, it's really clear that the EU has a larger share of A and B segment vehicles, Whereas in North America, we don't have any A segment vehicles and very few B segment vehicles. We really start with C segment vehicles. So naturally going back to the larger size, I guess everything is bigger in the US. In both regions, SUVs already account for more than 50% of the local production, and it's continuing to grow. There's a fascination with larger vehicles, of course. Before 2030, the EU will finally surpass the North American region in terms of aluminum content, with about 8 pounds of additional aluminum per vehicle on average, which for all intents and purposes is due to the EV-specific growth for Europe. As the US does not have an ICE ban, electrification is organically growing. And given the differences in EV penetration and the outlook, this is really why EV-specific components have a lower, but still very strong, but lower impact on the overall content per vehicle growth. In the previous Aluminum Association study that Ducker completed, aluminum sheet for body enclosures was the growth story. And although we see growth in sheet, albeit slower, extrusions, particularly for battery housings, which include its frame, the cross member, and the sill and rocker, which acts as a complete system, really shine in this iteration of the study.
Thanks, Abby. Elaine. Elaine, your analysis shows continued growth of the use of aluminum through 2030. Can you elaborate on what is changing in terms of product form, e.g. castings, sheet, extrusions?
Sure. So first of all, I don't know, Abby, if you can show us, yes, perfect. Our chart by product form, so casting, sheet, extrusion, and forgings. All of these aluminum product form will see their content per vehicle increase by 2030. So there is no loser in the story, and this is true in both regions. So I will focus on Europe first. Castings, let's start with castings. They will have the highest aluminum gains with 22 kilograms of additional aluminum on average per vehicle between 2022 and 2030. So that's huge. And castings will remain by far the largest aluminum product form. So it is today 123 kg per vehicle of aluminum casting on average, and to become 145 kilograms. So we all know with electrification, powertrain, transmission, driveline components all decrease, but they are being overcompensated by the new EV components, by the shock towers and large and mega casting in the body in white, even though large and mega casting are more in the mid to long term, and also overcompensated by the rising share of cast aluminum subframes and knuckles. If we talk about sheet material, sheet will still show significant growth with additional 14 kilograms of aluminum sheet on average per vehicle by 2030, which means a CAGR of 3.5%. And the aluminum sheet growth will mainly come from also EV-specific components. That's a common factors for all the product forms, I would say, with application especially for the ballistic protection under the battery and also the battery cooling plates. And outside the category EV-specific components, the aluminum sheet growth will come from closures, mainly for front and rear doors. If we move on to extrusions, extrusions are expected to achieve the most dynamic growth. Maybe you cannot capture it just looking at the bars, but the CAGR is the highest with 5.6%, sorry. And this results in a gain of additional 15 kilograms on average per vehicle of extrusion. This will be mainly linked to an increasing penetration in, again, tell me, EV-specific components. What a surprise. So especially for battery pack housing applications, but also in the body in white. Application will be in seals and even more in crash management system components. And the forgings, the last category on the right, small one, more of a niche, will have a limited gain of only 0.5 kilogram by the end of the decade. This is the least growing product form, but still growing. It's stable for wheels application and steering, but we see some increase in the chassis area for knuckles and 2-point links. So,
Thanks, Elaine.
Abby, for North America,
Yeah. Thank you. In the North American market, we find that castings continue to dominate the share by product form, and that hasn't changed over the last couple of decades. We've been analyzing this for the association. And that's natural, given the large aluminum wheels, the larger penetration of aluminum that we have for wheels, as well as our use of larger powertrains. This should be no surprise here. However, unlike the EA study where Helena shared castings in the European Union will grow by a CAGR of over 2%, the North American casting outlook is flat. And although there will be losses in castings for the ICE powertrain, other castings, as Helena had mentioned, with EV components will make up for that to keep the category stable through 2030. So despite the losses in ICE powertrain, we do regain some casting content for EV components. From an absolute year-over-year growth perspective, extrusions really lead the charge with about a 6% CAGR through 2030, and it's adding an additional 34 pounds per vehicle in that time frame between now and 2030. We noticed a trend where aluminum extrusions were finding more utilization within BEVs for the sills and rockers, which really work hand in hand with the battery housings to absorb and direct and redirect crash energy around the battery pack. For North America, sheet and forgings also do show growth, demonstrating 1.4 and 3.5% CAGR, respectively.
Great. Thanks both for going over the forms. We talked about the components that will be driving the highest aluminum content increase in kg or pound.
Yeah, great question, Craig. And as Elaine has just covered with the highest growth components, it's really no surprise that the components contributing to the most of the increase of the aluminum content in the vehicles are really linked to electrification or EV specific components as a category. They include the EV drive housings, which is a term we use to cover all in one units that integrate one or more motors, the gearboxes or the reduction gearboxes, as well as high power electronics, which for all intents and purposes lead the charge and are universally driving the aluminum content increases in both regions. The battery pack housings is another area, naturally also fit into the components driving aluminum content increases. And similar to the e-drive housings, common high growth components between both regions. For the EU, the large and mega castings, which Elena touched on, which we just scratched the surface in its potential, is classified as a high growth component. Again, for the EU, the ballistic protection and the systems designed to protect the battery seem to be a high growth component again for the EU, which also includes those battery cooling plates that Elaine touched on. For the North America, besides those e-drive housings and the battery housings, doors, so closures in terms of applications for sheet, as well as the sills and rockers are classified as high growth components.
Thanks, Abby. At least for me, your analysis makes it very clear that it's electrification actually that will be the strongest driver for this increased utilization of aluminum in cars. But if we look at Europe, Europe seems to be much further ahead than North America in this path to electrification. In the EU, we expect 31% of BEVs in 2026, up to 60% by 2030, versus in North America, you predict around 20% in 2026, growing to a bit more than 35 in 2030. So, Ellen, do you expect these electrification forecasts to concretize? And do you expect EU to stay ahead of North America in this conversion to EV?
That's a good one. Thank you, Florian. So maybe to start with, because these were several questions in one, a small disclaimer and explanation that we rely on third-party forecasts for the automotive production. We are not a vehicle production specialist, so we work with partners like, in this instance, Global Data, that you may know from the past as LMC Automotive. And also as an introduction and explanation, we had to work with slightly different forecast periods for North America and Europe. So for the North American study, we use a Q4 2022 Global Data powertrain forecast as a basis for our assessment. While for Europe, we worked with the Q3 2022 forecast data because we started the analysis earlier. And also important to note is that the vehicle scope in North America is slightly different, and it includes, beyond passenger cars, also light commercial vehicles. Why? Because the pickup trucks, as Abby has mentioned earlier, account for about 25% of the North American production, so we could not include them in the analysis. So based on the North American Q4 2022 forecast and based on the European Q3 2022 forecast, both regions, as you see on the chart, rebounding in terms of total production volume on top from the COVID-19 pandemics and supply chain disruptions, which had caused significant production pullback. So that's, of course, good news. North America is recovering at a faster pace and expected to get back to a 2019 production level in 2025. For Europe, in this forecast, the expectation is to get back to 2019 level in 2026. But here, I need to emphasize that if you look at the latest forecast, so we draw a curve in orange on top of the bars to show you the latest forecast, the powertrain forecast, they show that there is for Europe a significant revision down in the forecast, and that Europe is no longer foreseen to return to 2019 figures by the end of the decade. So there is an ease of demand that the market is currently facing. So now looking at the bottom charts to look at the electrification pace. So you see the powertrain mix. The top color, the darkest one, is to represent the BEVs, and the brightest one at the bottom is for pure ICE only, without any form of electrification. So you see there are significant differences here between North America and Europe regarding the BEV adoption, with Europe being very fast-paced in the conversion to BEV and expected, yes, to achieve a 60% of BEV share by the end of the decade. If you look at the latest forecast, this is even more. This is 64% by 2030. So honestly, these are very ambitious forecasts for Europe, especially when you look at the different sign pointing at a longer longevity of ICE. So to answer your question, Florian, if this will concretize, they are these signs. So in March this year, for instance, the ICE ban that has been decided in the European Union starting 2035 for new cars has been weakened, and some may say even annulled, by Germany's requirement to authorize e-fuel powered vehicles. Eventually, it sounds reasonable to assume that the ICE ban in Europe may be postponed or may even be lifted. Another sign is that quite recently in September in the UK, the ICE ban that was already forecasted for 2030 or planned for 2030 has been postponed to 2035. A third sign, the Euro 7 standards for ICE vehicles. At the end, they are being less strict than expected, and they will also contribute to a longer longevity of ICE vehicles.
Right. And just to add to Elaine's comments for North America, in the long term, the North American powertrain mix and outlook are really driven by two key factors. The first one is regulatory overtures, which include the Inflation Reduction Act, also known as the IRA, the EPA, and CARB following states. The second is realistically consumer acceptance of these different types of vehicles. The EPA, unlike what Helena shared as an all-out ban on ICE, which may or may not be lifted or pushed out, has really placed the emphasis on corporate average fuel emissions, or CAFE, as well as CO2 goals. Now, the beauty here is that they've lowered the CO2 goals or increased it to a point that it will be close to impossible to achieve without a very meaningful mix of full battery electric vehicles. And the 2026 and later goals are even lower, which further cements BEVs in the US landscape as being part of the solution of meeting those regulatory overtures, as I mentioned.
Mm-hmm. Very interesting. What do you see as the biggest challenges on the path to electrification in both regions? What changes might you expect to happen, and how well is aluminum positioned to meet these challenges?
Great question, Craig. As we kind of work with the association, we put together different scenarios, and part of that is, we touched on the regulatory pieces, which we have to monitor and update as we go through this, but also other challenges. I mean, we do have an election cycle that can alter the rate of BEV adoption, but let me be clear, we do not believe that we're at any risk of stepping off the electrification train. Okay, regardless of the political party, there are states that benefit greatly with the EV investments that are in place today and coming online, and the jobs that are being added to the millions of dollars being invested. So we're not moving away from electrification, but the rate of adoption may shift. We can't ignore the ongoing UAW strikes. It's a very relevant topic here in the US, and any hangover effect on revenue and profitability by the OEMs, which may alter their rate of EV launches, right? In North America, we've got 170 new EV launches, model launches between now and the end of the decade. So that might have a rate of introduction maybe being shifted a bit. Nevertheless, aluminum utilization is a driver of efficiency. Batteries are heavy and they're expensive, and using less of it is always preferred. It's the efficient way forward. Further, there are 4 key factors to monitor to achieve the voluntary goal of 50% EVs, EV sales mix in North America by 2030. Perhaps it's more realistic to look at it by 2035, but I digress. The first one is increasing energy density of the batteries themselves, and that has to come with solid-state batteries and other battery innovations, which do allow for better increased energy density while also reducing the battery size and the weight, which helps with packaging and the secondary mass savings as well. Raw material availability and cost containment for those batteries, including lithium and other precious metals like cobalt and nickel, is very important. The third is charging infrastructure, which includes both the density of the charging network and the fast charging capabilities that fundamentally needs to outpace the sales of electric vehicles, right? So the charging infrastructure has to outpace what we're seeing in the development and sales of the EVs. Last but not least is our charging grid here in the US, with the capacity and performance upgrades that really need to meet the goal of shifting to a greater share of renewable sources of energy creation as well, too. Elaine?
Oh, yeah. Sorry. I was just listening and was hanging on your lips. So yeah, these 4 critical factors definitely apply in both regions. So they apply to Europe as well. I would just specifically for Europe emphasize the urge for the European car makers to offer EVs that are affordable to a large share of the consumers. Shouldn't it be the case, it will pave the way to Chinese and other Asian OEMs with a more attractive price positioning to capture a significant share from European OEMs. So very important that there is a big shift in the offer in Europe on that point.
Thank you both. So in the absence of tailpipe emission, is vehicle weight reduction still relevant for EV designs?
Yeah, absolutely, Craig. That's a good question. In the North American markets, as we don't have a clear-out ban so far, which again could be extended or dropped on ICE vehicles, the remaining non-BEVs will have no choice but to be mass conscious to meet consumer and regulatory expectations of fuel economy and CO2. Remember, it's a CAFE corporate average fuel economy based on what is being sold and the mix. These vehicles that are non-BEVs will continue to utilize lightweight materials, including aluminum sheet and castings and extrusions and forgings, to really offset the powertrain-related CO2s that they have. BEVs must be part of that equation, however, we get to that 160 grams of CO2 goal that is in place. The unfortunate truth is that much of the mass savings on a materials basis that we've recorded and witnessed over the last decade is for all intents and purposes behind us. What I mean by that is that the average BEV adds nearly 1,000 pounds or more of mass to its equivalent ICE vehicle. Let that sink in for a moment. You know, we've been talking about saving grams on a vehicle basis, but now we're adding 1,000 pounds. Especially North American consumers are demanding larger and larger vehicles. Further, most EVs on the market today are loaded with technology and comfort features, power seats, massaging seats, right? And that had hundreds of pounds of mass for the components and the wiring, et cetera, that goes with it. Unlike mass savings that directly impact CO2, mass savings in an EV is really an efficiency solution. What this means is that any solution that increased the efficiency of the electric drivetrain must be considered. In EVs, range is king. And that's especially true for North America, given the larger distances we travel on average. And until the charging network, as I touched on, outpaces EV sales, range anxiety will grow. It's not going to go away. So this is a roundabout way to answer your question, Craig, that EVs, in spite of not having any CO2 emissions, will still require weight reduction to meet their range goals. This is why we see aluminum utilization much greater in BEVs versus non-BEVs.
Thanks, Abby. I totally agree with your analysis here. Shortly before, we saw extrusions and sheet growing, but casting still being predominant. Ellen, we mentioned the topic several times already today. To which extent are these large and mega castings impacting or even disrupting material choice? What is driving and what is even deterring adoption?
Okay, yeah, a big one. So fasten your seatbelt. Yeah, casting. So one of the beauties of the casting is the integration possibility. And depending on the level of integration, and maybe Abby, you can share the slide of the casting and ultimately the size of the casting, and link to that the size of the press you need to do the casting. We'll talk about integrated casting or large casting or mega casting. You can see it here in this chart. So these are example in the body in white. Actually, there is nothing new in utilizing casting for integration purposes. It's been done for years already. For instance, with integrated shock towers, which are combining the rear longitudinal as well. What is new is the large and the mega casting. So large casting. In the body in white, it typically integrates the shock towers, the rear longitudinal, and the cross members. We are talking about castings that weigh between 25 and 40 kg and require at least 4,000 presses with current state-of-the-art high-pressure die-cast technology. The mega castings on the right, which is also called giga casting by Tesla. So giga is not bigger than mega, it's just a different terminology a la Tesla, relate to even bigger castings. So these mega casting weigh typically between 40 kilogram and 85 kilograms, so that's really massive. And for that, you need presses with at least 6,000 ton clamping forces. Yeah, or even more. We are talking now about 8,000, 9,000, even 12,000 ton presses, but not in Europe. So these mega castings are used in the body in white for full rear end underbody or full front end underbodies that are cast in one single piece. Both the large and the mega casting are disrupting material choice, to address your question, Florian, because they displace the typical assembled solutions that we are using steel and or aluminum extrusion and sheet. So typically this would be a mix of material, which means this will displace the market share not only of one material, but of several materials. You were asking what drives the adoption for large and mega casting. The primary reason is that the one-piece casting makes it possible to reduce the manufacturing cost, the assembly cost. By replacing 50 to up to 100 parts by a single one, the assembly time and assembly cost can be significantly reduced. You have less manpower needed, less robots, little to no heat treatment, more compact production space, and again, a much faster assembly. On the other hand, there are a number of factors that make OEMs and tier suppliers reluctant to invest in large or mega casting technology. First of all, the capex. There are high investment costs implied at the beginning. This is why it would typically only make sense for a greenfield or a new line creation. Excuse me. The press are very big and costly. The dies are also very costly. You need a huge assembly hall. You need big cranes. And this is, of course, even more true for mega casting because they are bigger as compared to the large casting. Another potential deterrent for large and mega casting is the manufacturing process complexity. Even for very experienced foundries, aluminum foundries, it's not easy to cast such big pieces. So you have to deal with high scrap rates, especially in the beginning phase. So there is a learning curve, but you need to calculate this in your business case. And also potential quality issue, like we have read in the past with Tesla, with porosity and potential cracks. So it's not every foundry able to do large or mega casting tomorrow. Another barrier, potentially, or logistical challenges, both in terms of handling of the parts in the manufacturing, and also the transport. In case you are not located at the OEM plant and you need to transport this piece, which is more likely for large casting because you are less likely to transport a mega casting. But still, this is challenging. And it remains questionable what happens in case of an accident if you can repair a damaged vehicle using a mega casting, for instance, and how the parts will be aging.
Excellent. Thanks, Elaine. It's a very good analysis on a very top of mind topic for the moment. Abby, so we've been all talking about aluminum, but what about other materials such as steel and composites? Where do you see these in comparison?
Great, Craig. I'm happy that you asked this question. We've been tracking, as Helene and I had mentioned during the introduction, all sorts of materials that go into the automotive and transportation industries between North America and Europe. And one of the things that we've learned throughout the course of doing the work for the Aluminum Association and others is that the monolithic material vehicle is really behind us. The vehicle of the future will incorporate really the best of all materials and take advantage of each material's inherent strengths, and of course, minimize the material's weaknesses as well too. So essentially, what we're seeing more and more commonly being introduced to the market is mixed material vehicles. Advanced high-strength steels have grown in the past for several applications. Within the vehicle, within innovations, which such as press-hardened steels or roll-formed advanced high-strength steels. And coincidentally, these forming processes are also now available with high-strength aluminum sheet as well too. Steel's value proposition will certainly be valued more by some OEMs than others, and each material nevertheless has its own role to play. Composites have been around for years, and we're seeing them being more adopted into higher volume applications every day. From the bed of the Toyota Tundra to the liftgate of the Range Rover or the Nissan Rogue and several new SUVs, composites are also showing growth in the market. The fact that aluminum really plays nicely with other materials, and there's been such work done by the association and the industry to help with joining these mixed materials with aluminum, which also plays nicely with materials like magnesium and composites. And yes, even steel, it's a great benefit to this industry, and aluminum has a very good basis of growth there. Aluminum has really cemented its role in the automotive materials landscape, and we truly believe that it's got a very bright future, especially with the electrification trends that are upon us.
Thanks, Abby. We would have so many more questions now, but we have to keep our time schedule, unfortunately, a little bit. Elaine and Abby, again, I would like to thank you very much for all these interesting insights, for all your great analysis. I think you made it very clear, like you said, that aluminum has an automotive material, has a really bright future. And in my view, not only because it's light, but because of its many other advantages, and especially being one of the most significant enablers for the green transition here. Ladies and gentlemen, thank you too for listening. And before we start now with our 10 minutes Q&A session, I have to point out to you that the recording of this webinar will be available online, and that for sure we welcome feedback from you on today's presentation and also on any future topics of interest from the aluminum industry as well. So with that, I'm going to start our audience Q&A. We already got a lot of questions in advance, and I want to start with the first one for Elaine, if I may. And the question is, what are the perspectives and preferences for aluminum whose production has been made through low carbon footprint, specifically from green sources?
Okay. Yeah, I think the perspectives are very good because we have no other choice than moving in that direction. That's a must by regulation anyway, and this is also what consumer wants, and this is also what OEMs are requiring more and more. So it's very important for the industry to supply such kind of low carbon footprint materials, and it does not apply only to aluminum. It applies to all materials, all the same. And there are many initiatives in that sense. For instance, a few months ago, it was big in the press, the partnership between Hydro and Mercedes-Benz on the supply of low carbon footprint aluminium, I think below 3 kilograms of CO2 per kilogram of aluminium. So that will be delivered starting this year until 2030 with the goal to get to 0 kilogram of CO2 emission per kilogram of aluminium.
Thank you.
Excellent. Thanks, Elaine. Hey, Abby, are you seeing any new types of aluminum alloys with the move to electric vehicles?
Yeah, that's a good question, Craig. I mean, since we speak with the OEMs and the tier suppliers and the material producers, what we've really understood is that the transition to electric vehicles hasn't really changed the dynamic for alloy composition, right? We're still seeing the same levels of 5,000 series sheet and 6,000 series sheet for bodies and closures. We're still seeing the same level of 6,000 series applications for the extrusion, some 7,000 series, the casting alloys. So what I'd like to kind of mention here is that the transition to EVs does not require with it new alloys in order for it to grow. But what we are also noticing, and I touched on this, is that we are seeing some introduction of 7,000 series high strength aluminum, which could be hot stamped or warm formed as well too into certain applications that require that strength. So I think that's the beauty of the industries right now, is that there's a lot of innovation, a lot of investment in terms of how we could specifically develop alloys that are required. But the fact of the matter is that the transition to EV does not require any new alloys that we're currently not in the industry today. And just as a quick reminder to the audience, there's a Q&A button. Please do feel free to share any questions that you have from the presentation or other doubts that you have as well too. Thank you for those that have already shared some questions.
Thanks, Abby. I just had a look in this chat and I found a very interesting question for Elaine, maybe, or for you both. The question says the BEV share projections you presented for 2030 are probably the most bullish ones I have ever seen. How realistic are these in your opinion? You have provided some arguments, but one could also come up with counter arguments easily. A lower realization would mean a lower aluminum content on average.
Yeah, maybe I'll start this one off.
Okay.
I'll start this one off, Elaine. Mm-hmm. I think one of the things that we may not have conveyed through this presentation, but the Aluminum Association, the ATG, and the EA has the summary reports of the studies available. Aluminum content in both EVs and non-EVs are increasing through the years, right? So that's one fact that we did find. So, but just getting back to the EV projections, right? So Ducker Carlisle does not do their own projections. We use a third party called Global Data. I've seen other projections that are probably a little bit more bullish than what Global Data has projected, and perhaps others that are a little bit more conservative as well too. Realistically, the way that we look at it is that, as we said, there's a lot of external factors, and we talked about those 4 market conditions, which include solid-state batteries, the cost of the battery chemistry, charging infrastructure, as well as the charging grid, electricity grid, are all 4 of those need to really kind of develop. And we need to monitor that, and we could track that given those points that we can monitor. Of course, that kind of gives us an idea in terms of how we reach those goals and milestones. At least for North America, again, there is no ban on ICE vehicles. So in the meanwhile, we're finding that the OEMs are also developing their carbon neutral position, their 0 CO2 type of footprint, and they've announced very publicly in terms of their aspirations to go to zero emission vehicles. So at this point, all we could do is monitor it and follow through on a regular basis. And that's part of the reasons why we do the study for the associations on a regular basis, so we can monitor that and update the impact of that. Elaine, back to you.
No, you stated. I would like to reinforce a key message that it's true in both regions that the aluminum content per vehicle is increases in electric vehicle, but also in non-electric vehicles. So where the electrification path to slow down, we would still have an increase of the average aluminum content per vehicle. It would just be slower. I hope it answers your question.
Absolutely. The question, at least from our colleague here in the chat, I hope.
Perfect.
Great. And then looking at the Q&A section, there's think you touched on it a little bit in the presentation or discussion, Halan, but regarding light vehicle production, what are our assumptions on net trade through 2030 as we see the Chinese EVs increasing into Europe and North America?
Yeah, so we touched on it rapidly in the presentation, emphasizing that there is a risk for the European car maker industry to lose market share if the price that is being offered to consumers is not being made more affordable. Apart from that, I don't know if you would like to add something on this, Abby?
Sure. At least for North America, let's face it. I think the Inflation Reduction Act really sets some boundaries in terms of what's going to take place in order to qualify for the $7,500 or up to $7,500 worth of tax incentives. That's a big amount. By 2024, we are anticipating that to be an actual rebate at the dealer level, which would make it really interesting versus using it as a tax credit based on how much taxes you owe at the end of the year. But nevertheless, I digress. But the point here is that because of the IRA, the fact of the matter is, in order to qualify, vehicles have to be built in the USMCA, right? So that's US, Canada, Mexico. The batteries themselves have to be assembled and utilizing USMCA or USMCA free trade partner materials. And the housing, up to 50% now, and by 2029, 90% of the housing materials, which includes the aluminum we're talking about, has to be sourced from USMCA. So for the Chinese OEMs that want to penetrate the North American market, broadly the North American market, production has to be shifted here. Mexico, if you look at where a lot of the Chinese vehicle exports outside of Europe are, is going to Mexico, which is a feeder for South America, but also potentially into the US market as well too. So we're going to have to monitor that. I got to tell you that there's several excellent products that are coming out of China. So anything that increases the competitiveness of the market, and as long as it fits within the Inflation Reduction Act parameters, which means they have to be built here using local materials and assembled here, I think it benefits everybody as well too. But we have to, again, something we have to monitor to see how the Chinese branded OEMs are coming. This is in beyond to Geely and Volvo and Polestar, of course, is what I'm talking about. So it includes NIO and the other brands that are currently populated in China and Europe today as well too.
Yeah, and to add to that, you may know about a German premium OEM that is partnering with a Chinese OEM in China, taking over the chassis structure. So we could expect probably that more of these partnerships will take place, not just to serve the Chinese market with European brand, but also the reverse.
Thanks. There is one question from the questions which were submitted in advance, which I would like to ask you. It's also regarding the topic, which is of utmost interest for so many of us larger mega castings. So the question is, are you seeing differences in adoption of this large or mega casting technology in North America versus Europe?
Yeah. Maybe Helene, I'll start this off, and you could come in with any sort of additional commentary. In North America, I mean, we have to admit that Tesla is an American manufacturer for all intents and purposes. So they challenge the status quo by asking, do we need to build vehicles the way that we've done for over a decade, for over a century? And they introduced that mega casting, right? So as we see the adoption of mega castings increasing, there are several OEMs that have indirectly announced that they will be investigating the solution. But for all intents and purposes, as Helene mentioned, the benefits of utilizing a mega casting are really very specific. There's a narrow set of conditions that we really truly believe that the OEM has to really kind of fit within to really benefit from that, right? So there's no right or wrong answer here. Of course, every OEM has their own set of criteria that they utilize to select what's the manufacturing process. But fundamentally, at least for the North American market, what we do find is that the benefits come from a brand new facility, right? Or a situation where the robotics and the welding cells and the stamping facilities have outdated themselves and there's a new investment required. In that instance, there's a CapEx opportunity there to save with these types of machines, right? And not only that, the OEM could benefit from the knowledge of integration of multiple pieces of stampings and whatnot coming together as one cast solution. So there are some parameters, at least in North America, that we see for OEMs to consider this. The second, of course, is the actual volume, right? So there's a multiplicity effect in terms of the annual production volumes of the vehicles and the number of casting machines required. The third piece that we see here, again, for OEM adoption is also really thinking about the recycling. Helena touched on the fact that there's a high levels of scrap, at least initially, and Tesla's proven that we could bring the scrap rates down, but it's a very specific alloy. The chemistries are very specific, and so we have to figure out what that scrap stream also looks like for mega or giga castings. So I do believe that there is going to be some more announcements being made. I don't have anything official to share with the audience just yet, but in that same token, large castings, which include 4,000-ton and 6,000-ton machines for integrated shock towers and longitudinals, subframes and other applications of the vehicle are also increasing pretty significantly in that same time. Rio castings are also another option to consider. But anyway, I'm running the clock out here. So Elaine, anything else to add here?
Yeah, maybe that Tesla has obviously been the pioneer with mega casting and started in North America with that, and then did it in Europe. But there is no such unique solution as mega casting because the alloy could be different, the process being used can be different. So the mega casting from Tesla will not necessarily be the mega casting from Volvo and the other one who will be following. So when we compare the two regions, it seems like Europe seems to be less hesitant to go for large casting as of now. We have a number of announcements in that directions. Mega casting is limited to Tesla and Volvo so far in Europe. And in North America, we get the impression that there is more of a wait-and-see position with regards to large and mega casting. But I guess in 1 year time, maybe if we talk again about that, the picture will be a different one. We already anticipate in Europe that there will be new applications for large and mega casting. You talked about the one-piece subframe, but you do not necessarily need such big press for that. But what we could do is for big BEV battery housing, a one-piece casting, or for the battery frames of a BEV pack. And Volvo has been at the Aachener Engineering Days a few days ago showing such prototype and is clearly looking in this direction. So also something to watch. And very important will be the intense R&D work that is being done in both regions to improve both the casting process for large and mega casting and the alloys that are being used, because we need to achieve a better castability, a higher product quality, also a higher output in terms of manufacturing efficiency, and also definitely need to be able to utilize aluminum material with a significant share of post-consumer scrap.
Thanks.
So thank you both. I think we're coming to the top of the hour here, so we'll hand it over to Megan.
Super, thanks so much. And with that, I will go ahead and bring this webinar to a close. I would like to thank our speakers for sharing insight with us today and ATG for helping to make the event possible. We will be making slides and an on-demand version of the webinar available. Thank you for listening and goodbye.
Thank you, everyone.
Goodbye, everybody. Thank you for the attention.
Bye.
Bye-bye.